Hello and welcome to today's lesson. We're in the midst of chapter 5 and today we are going to be covering section 2, which is talking about congruent polygons. So remember, to be a congruent polygon, you first and foremost have to have the same shape. You cannot be comparing a triangle to a quadrilateral. So they first and foremost have to be the same shape. And then remember that corresponding angles need to be congruent. So if I have, let's just pick a triangle here, and then we have another one going this way. So remember the corresponding angles. So this angle here, where that short side and the really long one, short side and really long one, those corresponding angles need to be congruent. And your corresponding sides need to be congruent. So this side would need to be congruent to this side congruent to this side, and the third side's congruent, okay? Along with this angle would have to match this angle, and this side, or that angle, would match that angle. So corresponding angles and corresponding sides must be congruent. So here we have two different triangles, and it looks like angle A and D are congruent. They both have single marks. Angle E and B both have triple marks. F and C both have double marks. So we can say that they are corresponding. And then they go through the sides and do the same thing. So writing a congruence statement. So I think for the most part, you guys probably have an okay handle on how to write the congruent statement. It's the directions that catch a lot of kids on a test or quiz. They're not exactly sure what a congruence statement is. Well, a congruent statement is going to say that triangle ABC is congruent to another triangle, and make sure that you get the corresponding parts in order. So A has a single mark, D has a single mark, so A and D are both first. And then B and E, they put second, and they have triple mark, triple mark. So the corresponding has to be in the same place. We could not say triangle ABC is congruent to triangle FED because A does not correspond to F. So make sure you get the corresponding parts in the correct order. All right, given triangle JKL is congruent to triangle TSR, name each congruent match. Well, angle K is congruent to, and let's look, angle K is in the middle. So what's in the middle over here? And we would say angle S. LJ, so LJ would be from back to front. So we're going to have RT, not TR. You must put them in the correct way. So if they said LJ, then you need to say RT, and don't forget your segment mark above it. So make sure you get the corresponding parts in the correct place. All right, in this diagram, they're telling us DEFG is congruent to SPQR. So we need to find the value of X. So typically what I do in here is if they want me to find X, I go find the thing that has X in it. Well, one of them is the side QR. So QR. Now, QR is the last two letters, so I don't just look at the diagram. I usually go back to my letters, and since QR is the last two letters, then I go to the last two letters here. So QR has to be congruent to FG. So QR is 2x minus 4, must be equal to FG, which they say is right here, is 12 feet. Now, as luck would have it, I only have one letter in here, so I can go ahead and solve this. And 2x equals 16, divide both sides by 2, so I find out that x is 8. Now, I could have started with this angle Q here, because angle Q also has an x into it. So angle Q is going to be congruent to angle. And again, I'm going to go back to my letters. So angle Q is in the middle, second from the end. So that goes to angle F. So angle Q is 6y plus x, and that must be equal to angle F. and F is 68. So if I would have set this one up first, I now have two unknowns, an X and a Y. I cannot actually solve that right now because I only have one equation. However, I just found out in the last one I just set up that X is 8. So I can now substitute here in place of X, I can put 8 and then go ahead and solve this. So it looks like 6y is going to be equal to 60 because I'm going to subtract 8 from both sides. And then when I divide by 6, I get y is equal to 10. So x is 8 and y is 10. But do you see how the letters help me set up my algebraic expressions? So remember, this algebraic expression is required on any tests and quizzes. All right, next sample here. Is B, angle B, congruent to angle Y? What do you think? Is angle B going to be congruent to angle Y? Well, let's just say this is 20. So that's 20. This has to be 20. And let's just say this is 80. So that's 80. This is 80. All right, so 80 plus 20 is 100. What does that leave for angle B? Well, it leaves 80 degrees here, and 80 plus 20 is 100, so that's subtract from 180, that leaves 80 here. So is B congruent to Y? Well, what if I would have picked different numbers? What if I would have picked this to be a 50-degree angle? Well, then the single mark, this would be 50 degrees. And if that's still 80 and that's still 80, so now what do we have? 130 minus 80. Wow, I keep doing that. So now this is 50, and that leaves this to 50. Is that always going to happen? Even if I have an odd angle here and just call it 61 degrees, will that still happen? And the answer is yes, as you guys have probably already surmised, and this is called the third angle theorem. If you have two triangles, and two of those angles are congruent to the other two angles in the other triangle, then the third angles must be congruent. And this is called the third angle theorem. So if two angles of one triangle are congruent to two angles of another, then the third is congruent. So this is a theorem that comes up, so you should probably pause the video and get this written into your notes, something to reflect and look back at. So the third angle theorem. All right, the last thing we're going to do today is write this proof. So how can we get triangle ACD congruent to triangle CAB? Well, in order for the triangles to be congruent, what did we say in one of the very first slides? That three angles need to be congruent, and do we have to have three sides congruent? So, do we have to have 6 things in our triangles to get here to be congruent? So, according to this diagram, I have AD is congruent. So, AD, single mark to no mark is going to be CB. Okay, and isn't that given by your diagram? All right, then I'm going to go with these double marks here. So DC is congruent. So DC, I went nothing to double, so that must be BA. And again, those are given marks on this diagram. All right, then it looks like we have angle DAC is congruent. So I'm naming the angle with the single mark. So over here, I'm going to name this BCA. And again, that is given to me by this diagram. I didn't have to make anything up. I didn't have to use any theorems. It's given to me. Now I also have a double one over here. So DCA, angle DCA is congruent to DCA. So what's that? BAC. And again, that is given information. Now you could have put all of that in step 1, and then this proof would seemingly have less steps, so it doesn't matter which way you do that. All right, is there anything else that this diagram is telling me, because I only have 4 things congruent and I need 6. So is there anything else that this diagram is telling me? So is there a theorem we just learned? Is angle D congruent to angle B? So that's the theorem that we just used, and it is called the third angle theorem. Guess I should put my steps in here. 1, 2, 3, 4. All right, so now I have this angle congruent to this angle. So I have 5 things congruent, but I need 6. So is there anything else that I can say in here? Is this diagram giving me anything else? Well, do we have a property that says AC is congruent to AC? Isn't that called the reflexive property? So the reflexive property of equality, AC is congruent to AC. Well, now do I have 3 angles and 3 sides congruent? So can I say triangle ACD is congruent to triangle CAB? And isn't that definition of congruent polygons? So if I get all the angles congruent and all the sides congruent, then those polygons will be congruent. All right, so remember, if we're doing triangles, we have to get 6 things congruent. If you have quadrilaterals, you'd have to get 8 things congruent. So you'd have to get all 4 angles and all 4 corresponding sides in order to use definition of congruent polygons. And the big theorem that we learned today was the third angle theorem. So if 2 angles of one triangle are congruent to 2 angles of another, then those third angles must be congruent, and that's called your third angle theorem. All right, good luck on your homework.